Hey everyone, welcome back to my channel Leela Web Dev. In this video, we will try to understand the threads in the programming. Now we will enter into our concept that is nothing but threads in the program. So what is this thread and how they work and why they are useful for the efficient programming? Let's try to understand. So what is the definition of this thread? So let's try to understand about this one. So let's go into this here. So now what we will cover today in this video, let's try to see what is a thread, the basic definition and the core concepts. We'll learn it, and how the threads in a process, so how the threads operate within the process we'll try to see, and what is the difference between threads and the process, and what is the performance benefits that we can achieve by using the threads. Let's try to see these all the things in this video. So normally what can I say is a thread is nothing but a unit of execution inside a process. So now you should be able to understand about this thread thing. It is nothing but a unit of execution inside a process. Think of a process as a program running on your computer like a web browser or a game. So that means here you can think the thread is also something like a process, which is like a process also running in your application. You need to understand that one thing, that every process, so whatever the process you are having, every process you will have at least one thread to do the work. So if it does, so it doesn't have, you can't have any process with the zero threads. At least one thread will be there for every process. If you have the zero threads and all those things, it doesn't work. So every process will have at least one thread. Each thread has its own program counter. So this one, you know about this one. So each thread has its own program counter which keeps track of what instruction it's executing. Now here the concepts you will be able to understand, that process, thread and program counter. So these are the concepts. Now you will be well aware of this one all. So each thread has its own program counter. So now here the same thing, the same as how the process will have the states, the thread also will have the states. One is running, ready and sleep. So running state means it is executing in the CPU. So that is, the thread is currently utilizing the CPU and executing its instructions. Whereas the ready means, so it is ready, it is waiting for the CPU to pick up the task. So the thread is ready to execute, but it is waiting for the turn in its CPU. And the sleep means, so paused, it is waiting for something. So the thread is inactive, perhaps waiting for a network request or a timer to complete, something like that. The operating system CPU scheduler treats each thread as its own unit, managing transitions between these states. So the CPU scheduler or this dispatcher, so it will try to transition between the states. So threads in a process. So I already told you, right? Every process has at least one thread. By default, every process starts with one thread. So that is one thing you know. But you can create more using a system call. So here the system call means the operating system call. So you can create more threads using a system call, which tells the operating system to add another thread to this process. So in a process, in the same process, you can use the system call to create another thread to this process. There is usually no limit to create how many threads you want. For a single process, you can have thousands of threads unless your operating sets one. Okay, so you could have thousands of threads, though you probably don't need that many. So how threads work together? First, thread 1 running, one thread is actively executing in the CPU. So now next one is thread 1 makes a blocking request and it goes into the sleeping state, and again CPU switches to thread 2 which is in the ready state. This switching happens extremely fast, allowing the operating system to juggle multiple threads and keep everything running smoothly. So why we need to use the threads instead of process? So now you can able to understand that you are having the threads. The same thing how the process behaves, the same thing we can able to understand the threads also behaving. So why can't we create another process instead of having the thread? So here the things comes. So why not just create another process instead of a thread? So while you can create another process, and in some systems like Linux, a thread and a process are quite similar. Threads offer significant advantages that make them preferred choice in many scenarios. But thread has some advantages than the process. Let's try to see. So advantage 1 is speed. So creating a thread is far more 5 to 10 times faster than creating a new process. So one thing. So if you want to create a thread means it can be 5 to 10 times faster. The speed advantage comes from less overhead as threads are part of the same process and do not need to duplicate as many resources. Memory to second advantage, shared memory. So you are having a process and you can easily share the memory. So threads within the same process can easily read and write to the same piece of memory without involving the operating system. So whereas the process memory sharing also you can able to do it, but it is possible, but it is very complex and it is slower, requiring special system calls and arrangements. So that's why thread memory sharing is very easy. So you can have a process, inside this process you can have a shared memory, and all the threads can able to access that shared memory, and you can modify the data using the threads. So second one is background task. Threads excel at handling background tasks while keeping the main execution path responsive. So the main thread will be always responsive, and the threads will execute the background task. So web server example, main thread handles the user request. Secondary thread logs the details, request path, IP address, and all the things. Main thread stays focused on the critical tasks. So example, improving performance with the threads. Single thread always process large string. Processing a large string takes 5 seconds. Split the task. Divide the string into two tasks. Parallel processing, assign each part to a separate thread and time reduced to 2.5 seconds on dual core CPU. So that is the main thing. So this parallel processing approach can dramatically improve performance for CPU intensive tasks. Scaling with more cores. So with an 8-core CPU and 8 threads, you could theoretically reduce processing time to 1/8 of the original. So real world in practice, the speed up is slightly less due to thread communication overhead, synchronization requirement, and memory access patterns. So you need to understand about the thread scheduling also. How does the CPU manage the multiple threads? Through a process called scheduling. So for example, CPU schedule picks a thread from the ready queue, and thread runs for a short period of time, and CPU saves the current thread state and loads another, and first thread returns to ready state queue. So it will again, the cycle repeats like this. So the rapid switching creates the illusion that threads are running simultaneously even on single core CPU. So thread challenges, synchronization. When multiple threads access shared data, problems can arise. So something like race conditions, when the outcome depends on the sequence of operation, when threads interfere with each other operations. Solutions include logs, mutex. So these are all the things we'll try to learn afterwards. So this one also we'll try to learn afterwards. So now here the thread implementation difference. Windows implements threads as distinct entities with their own scheduling and synchronization mechanism. Linux uses a lightweight process where threads and processes are similar, differentiated mainly by shared resources. Employs a hybrid approach with Mac threads at the kernel level and P threads at the application level. So the core concepts remain consistent across all the platforms. So here, when to use the threads. So these are all things which we'll be able to see. IO bound applications, web server. So here we need to use the threads. So background processing, logging, monitoring, UI responsiveness, keeping interfaces smooth, and parallel computation on the multiple core systems. So very simple sequential task when synchronization would be too complex, when process isolation is more important than performance on severely resource constrained systems. So there we need to avoid it. Thread programming in different languages, Java. So you can use the thread class and runnable interface. And in Python, we can use the threading module. And JavaScript, we can use single thread with event loop, web workers for background processing. And C#, we can use the thread class, task parallel library for modern concurrency. So each language provides its own abstractions, but the fundamental concepts remains the same. So here that is nothing. So key takeaways, what we have learned now. So thread basics, thread is a unit of execution inside a process, and every process has at least one thread. So here thread can be in running, ready, or sleep state managed by the CPU scheduler. So threads are faster to create than process and can easily share the memory. And threads excel at background tasks and splitting heavy work to run faster on the multiple core CPUs. So that's it guys about this one. So thank you for watching. So don't forget to subscribe and hit the bell icon for more programming tutorials. And if you have any doubts or anything, drop your questions about threads in the comments below. So that's it guys. If you like this video, give this video a thumbs up, and if you found it helpful. Thank you.